On screen we have the air conditioning system of a building through product distribution, air handling unit, chiller type water cooler, and boiler. Today we present an air handling unit system in HVAC. Stay with us, and remember to subscribe to the Confer Empresarial channel. Let's start by numbering the parts of the installation. 1. Chiller. Pump to transfer the water to the cooling tower, which is responsible for cooling the chiller condenser. 3. Cooling tower to cool the water from the condenser, and this way the heat from the chiller is expelled to the environment. 4. Primary pumps to bring the ice water to building 6. Boiler to generate hot water. When the installation works in heating mode 7. Primary boiler pumps 8. Secondary boiler pumps 9. Heat exchanger for chilled water circuit 10. Heat exchanger for boiler circuit in heating mode. 11. Air filters. 12. Air supply duct. 13. Entrance dumpers to carry out the control of air renewal with fresh air from the outside. 14. Exit dumpers to control the expulsion of air to the outside. 15. Return damper to control the recirculation flow. Now we are going to explain the operation of the system in cold mode. The water leaves the chiller, for example, at 7 degrees Celsius. The water is directed through the pipes to the air handling unit. The water enters the smoke exchanger. The air from the outside, for example, at 30 degrees Celsius, enters the ducts and the smoke. The water returns to the chiller with a temperature of 12 degrees Celsius. The air is cooled, for example, 12 degrees Celsius, and is sent by the UMA to the building's ducts. The air reaches all the places where it is required. The air returns to the UMA to be conditioned again. Part of the air that returns is expelled, and the other part returns to the UMA. The percentage of air that is expelled to the outside environment must be controlled by a sensor in the air handling unit. The expulsion of already heated air is a waste of energy and must be carried out due to hygienic requirements. If, for example, the AHU sensor of the air handling unit, in charge of measuring the ppm values or AHU concentration inside the building, determines that 10% of the recirculation flow must be replaced, this percentage must be sent through the corresponding grid to the outside environment. Now the same value of expelled flow must enter the system again through another grid to maintain the pressure and supply at the appropriate values. In order for the installation to work in heating mode, the boiler is now required to work, and not the chiller. Now the heating mode exchanger works. Chiller. The air is also sent through the building's ducts, but now it is hot air. Let's take a closer look at the operation of the air handling unit again in cooling mode. This is the air intake from the outside towards the air handling unit. This is the air conditioning outlet through supply grids to the premises. This is the air conditioning riser grill to start the recirculation of the air.
This is the recirculation duct which returns the conditioned air to the air handling unit.
The air outlet control box opens or closes the air supply to the premises, depending on the temperature inside the room. When the air handling unit has a fan with a frequency inverter, the CRPM can be changed to only send the air that is needed. We are going to study the main parameters that must be controlled in the air handling unit.
On the screen we have a control panel of the automated air handling unit.
The parameters that we can observe are relative humidity of the outdoor air, which represent the amount of water vapor present in the air expressed as a percentage. Moist volvus temperature of outside air dry volvo temperature. Remember that the dry volvo thermometer indicates the ambient temperature, while the wet volvo thermometer gives the temperature due to evaporation related to the thermal sensation. Indoor air return temperature sensor. This is the temperature of the air returning from the rooms. Return air relative humidity sensor. Return air AHU concentration sensor. This parameter allows the air handling unit to know how much air it needs to renew. As we can see, the unit of measure is parts per million ppm. For example, in this case the concentration is 692 ppm. Let us remember that carbon dioxide is one of the most common pollutants and that most affects human health in buildings. Controlling their presence in buildings is a very important help in health and comfort in homes. The different reference studies warn that the recommended levels of carbon dioxide AHU, maximum recommended, inside homes, rooms and other buildings, are between 400 ppm and 800 ppm. Return fan speed. In this case it indicates that it has 63% of its speed, which indicates that we are in the presence of a fan with a frequency inverter. Return air smoke sensor. Supply duct pressure sensor, that is the pressure that the air has at the outlet of the fan. Supply or intake air smoke sensor. Supply or intake air temperature sensor. In this case the value is 61.3 degrees Fahrenheit. Supply fan speed. In this case it indicates that it has 50% of its speed, which indicates that we are in the presence of a fan with a frequency inverter. Freezing sensor is responsible for monitoring the heat exchanger to prevent it from freezing. Percentage of opening of the water, which is responsible for cooling the air of the air handling unit. In this case it is 55% open. Pressure sensor. This sensor measures positive, negative or differential pressures. In this way the condition of the filter can be measured. In this case the pressure drop is 0.2 inches of water. Air mixture temperature sensor. Let's remember that at this point we have a mixture of air made up of new air from outside and recirculated air that comes from the rooms. Damper opening percentage to control the renewal air that comes from outside.